the next concept I want to introduce, which is buffering, or buffering capacity of a soil. Buffering, from a chemistry standpoint, means that it is a chemical substance which is allowing that pH to be somewhat stable or resisting a change in pH. That's what a chemical buffer does. So if you have a substance which is highly buffered, acidic materials and or alkaline materials can be added to that, and we would not expect to see a substantial change in the pH of that solution. Well, I want to relate buffering to the soil and soil pH. If soils have a lot of readily exchangeable cations held on the colloids, then they, of course, are going to have a much higher buffering capacity than those soils that have a very low cation exchange capacity. That is to say, soils with a high CEC or cation exchange capacity have a much greater reserve supply of cations to go into solution, as others are either added or taken out, away from soil solution. Now, what contributes significantly to that soil's cation exchange capacity? Type and amount of clay and or organic matter content greatly influence the cation exchange capacity of the soil. So when we look at this from a field soils or application standpoint, we would expect soils that have appreciable amounts of clay, especially 2-to-1 expanding types of clays, and or appreciable amounts of organic matter, are going to be much more highly buffered. In other words, they are going to be able to resist changes in pH much more readily than those soils which either have low amounts of clay, which is typical of coarse sandy textured soils, and or have a corresponding low amount of organic material. If we don't have the exchange sites, we don't have the cations held there to go into solution to take place of others to help offset the effects of acidic or basic cations being added to the soil. Therefore, those soils that are sandy and or low in organic matter have low buffering capacity. It would not take as much material, be it lime or gypsum, depending on which way we're trying to go, to modify the pH of those particular soils due to their low buffering capacity. They don't have the ability to resist that change in pH as readily as do those soils with a higher buffering capacity.